capable the substance to do the salt. So we have soluble and insoluble. So we will take some separate examples here. We will take an example of an ionic compound. Ionic compound. Like the example that you in your box is lithium chloride. If we dissolve, if we make dissociate for lithium chloride in waters, what it forms, guys? What does lithium chloride form?
Lithium and chloride ions.
Lithium ion positive plus chloride ion. This is process here is called hydration. This is called lithium hydrated ion, and this is chlorine hydrated ion, because it's surrounded by water. So how does this happen? If we have a beaker here, and this beaker have a water solvent, and we have here lithium ion, the solvent, and we have a chlorine ion. So how this is already separate, and how what happened actually. As you see here, guys, you will find this is the lithium positive ion, and here we have the chlorine ion, negative ion. We know that water is a polar or a non-polar compound. Very polar. Very polar. The structure of the three model of oxygen like this, right? Oxygen, and here is the hydrogen. There is a partial charge of the oxygen. It's partial what? Negative, because it's the highest electronegativity. Here, partial positive charge. The water molecules here in the solution, if we zoom in the solution particle to see what actually happened for the lithium chloride and the chlorine, you will find that chlorine here is a negative ion, right? Yes. What do you think, which side of the water molecule will surround the chlorine? The hydrogen, because it's on the positive side. So when you will find the water molecule is surrounding the chlorine ion from the positive side of hydrogens. Okay? Okay, guys? It's the oxygen, and it's around the chlorine. But what about the lithium? From the oxygen side, yes. Really don't know. From the oxygen side. Because the oxygen is have a partial negative charge up on it, and this is what we found as a solution and how the solution formed. This is the oxygen side. Here is the hydrogen side, guys. Okay, understand it that way here. This is a formation of solution in ionic compound. What about if we have, of course, what we call this lithium ion, hydrated or unhydrated? Hydrated. Why we name it hydrated? It's surrounded by water molecule. Some ions, guys, ionic compound already have a water molecules embedded in its structure. This is, for example, copper sulfate, CuSO4. And then we put dot to represent the number of water molecules inside. This shape here, solid particle, is called the hydrated compound because the water molecule is embedded in its structures. When it's dissolved, you can see that it's forming a specific structures here. This is the structure of that, guys. SO4 here, SO4. The SO4, when it's dissociated, it is the same case here like the ionic compound because the copper sulfate is also ionic. So the copper, when it's dissolved, what kind of ion it's for? Cu positive 2. So Cu positive 2. And the sulfur is a polyatomic group that forming an ion with negative 2 charge. This is the oxidation number for the polyatomic ion here. And you could see that there is a water molecule that surround the chlorine and from all directions. We have here water molecules, we have here water molecule, also here a water molecule, here are water molecules. And you could see that there is a pattern here in this first group. Okay? and there is the electrostatic forces that hold this, all of them together. Because we know that it's you see the shape of it?
Yes.
And all of them dissolve in
What?
Alaikum salam.
Yes.
Yeah.
okay.
So where is the fifth molecule?
Okay? So now you understand the flow of the lesson, guys. From the beginning we talk about the factor, then we talk about the categories, then we take some example of the solubility, how it's happen, how it's dissolved. If you observe that, yes.
This one is ionic, right?
Yeah, and this is also is ionic, but hydrated ionic, because the water molecule is embedded into the structures of the crystal, called the hydrated. If I wanted to convert this hydrated compound to anhydrous or unhydrated, what am I supposed to do? It's a water, so if I heat it, it will evaporate and lift the copper sulfate alone, anhydrous. Okay? I will get back, don't worry, I will give you a time to write, guys, don't worry. Here is, as you see that, we understand how the energy compound is solved. But what about if it's a non-polar compound, according to the rule, like dissolves like?
Yes.
If it's a non-polar compound, dissolved, if we have two liquids, for example, here we have toluene that dissolve in a lithium chloride. As you see that the salt is precipitate here. This is a solid and toluene is a liquid. We have here a precipitations. You could see the separations between the two components here. We call this immiscible. What's the meaning of immiscible?
Yeah.
They are not mixing together, but if they are mixing together, like ethanol and water, they are miscible. Okay? What actually determined that? Guys, the solute and solvent, as we said, there is a rule it's called like dissolves like. It's mean what? Anyone? Polar dissolve in polar and non-polar dissolve in non-polar. This is mean there is a kind of similarities between them. For example, the ethanol and water, they have similarities. They could form a hydrogen bond. That's why the ethanol could dissolve in water. But here, if we try to, like in your book in the page, you could see that he gave you an example of the wind that dissolve in water. And he said that this compound is immiscible. Page 398. Do you see the figure 2.7, guys? Right? You can see that why this happened. What kind of intermolecular forces does the water have? What kind of intermolecular forces the water have, guys?
Hydrogen bonds.
Hydrogen bond. This hydrogen bond is like, it's forming like a kind of layer. So, do you see that? Do you see that?
Yes.
Okay? A kind of layer. So this layer like push the particles of the non-polar compound above it to form a layer. This is like the oil and water. Do you see the oil and water? You could see the separations. And what we call this immiscible or miscible? Immiscible. It's because it's not actually combined to each other. It could not actually form a
They are
solution.
separated.
Okay, guys?
Yes.
Now, when a solid is the first add to a solvent, solute molecules leave the solid surface and move about, run them in the solvent. As more as solute is added, more collisions occurs between the solid particles. Some of the solute molecules they return to the crystal. So what is this? If we get back to the solution, that there is two processes that happens actually that forming a case of equilibrium. When we talk, guys, about the solutions, and we know that if I have a sugar, for example, okay, sucrose, and the table sugar, and we have a water. So the sugar I will represent it with, this is blue dot, and the water, let's represent it by this color here with the red, the solvent, okay. The sugar, guys, when it's actually here, this is the particle of the sugar. And this is the particle of the water is dissolved inside. In these solutions, we still have some kind of sugar powder under here. And the solution is actually capable to dissolve more. What we name this solution?
Listen.
I'm not talking about, I'm talking about the amount of solid, saturated or capable to dissolve more amount. Unsaturated, it does not reach the limit here. Then this more particle is keeping to dissolve in the solution until it could not be any more particle at the same temperature, of course, at the same temperature, guys, could not be dissolved. So what we call this? Saturated solutions, okay?
Yes.
Then we raised the temperature a little bit, and then we left this compound, we dissolved more, and then we left it until it's cooled down, and there is an excess amount in the solution is already dissolved. We name that supersaturated. In this process, guys, if you have a seed solid of this sugar and you put it inside it, there is a way that this is solid particles here. Do you see this is solid particle here with the blue color here?
Yes.
Will collide together to form the solid again. When it's formed the solid again, we name this process recrystallization. So we have here two opposite processes that happen. This is two opposite process is called the dissolution, amount of solid dissolved, and another solid is another recrystallization. And when we have two processes that happens in equal rates, two dynamic processes that happens in equal rate, we name this equilibrium. This equilibrium actually happens because the amount of solid particles that separate to form the solution is equal to the amount of, or the rate of the amount that of the particles that collide together to form the solid again. And we name that solution equilibrium. Okay, understand the saturated, unsaturated, supersaturated, and the equilibrium that happens. Understand how substances dissolve in each other, so like dissolvents, like the product dissolving food.
Yes.
So right now we finished two main ideas. How much the time, guys?
25 minutes.
25 minutes. We have 5 minutes only, so we will leave 5 minutes. This is for any questions that you have, and that's for today. So if you have a questions, you could raise it up, guys. Okay, thank you.